First spinner, second spinner. First spinner's got, you got 1, 2, and 3. The second spinner has 4, 5, and 6. You know, I'm talking about spinner, just something we can, I just got an arrow there. I'm going to flick that one, get a number, flick that one, get another number, okay? All right, so let's say these two spinners are used to form a 2-digit number. And just for clarity, this is going to be the first digit. That's going to be second digit, okay? So we're going to spin that one. That's going to give us our first digit. Spin that one to be the second digit. Okay. All right. What is the sample space here? Well, what do we mean by sample space? Sample space just means list all possible outcomes. What are the possible outcomes here? Well, I could spin and get 1, and then over here I could get 4, 5, or 6. So what would be the smallest one number I could get? 14. Okay, 14 would be one possible outcome, right? Because I'd get a 1 here and a 4 here. Or I could get, next, I could get a 15, right? 16, with me on that? Then I could get, what would be next? 24, 25, 26, or I could get 34, 35, 36, right? Those would be the outcomes I could get. With me, okay. All right, number 2. All right, then, what is the probability we spin a number greater than 25? What is the probability we spin a number greater than 25? Well, probability is the same here as it was before. Probability that it's greater than 25, we take the successes over the total there are. What would that be in this case? Which ones are successes? Anything greater than 25? So 26, 34, 35, and 36 would all be the ones greater than 25. So there's 4 of them. Over, divide that by the total there are. How many total? 9. There you go. Okay? So probability is the same no matter what. You take the successes there are divided by the total possibilities. Okay? All right, now let's look at a couple of special ones here to make a point or two about the range of these values, okay? So far, if you think about it, we've always got, a fraction, 4/9. That's 44% or something like that. 50%. We got a 25%, I remember. Let's think about a little more here, though. All right, so let's go and roll a single die. What is the probability I roll a number negative number? Okay. What is the probability I roll a negative number? Well, that's obviously not possible, but let's think about what the probability of that is. Rolling a die, What's the probability I roll a negative? Well, success-wise, how many of those could I roll that are negative? 0, okay? There's 0 successes for that particular case out of how many are there possible? 6. 0 out of 6. Now what does 0 over 6 work out to be? Is 0. Okay, yeah. Yeah, like I said, this was an impossible event, rolling a negative number when I'm rolling a die. Well, doesn't that make sense then that the probability of that happening is 0? Yeah, an impossible event always has a probability of 0. An impossible event always has a probability of 0. Okay? 0 chance of occurring. Makes sense that the probability would be 0. Say it again? Yeah, the total possibilities is still 6. It's just that the top number is 0. Yeah. Yeah, I mean, we're still talking, this is how many there are possible. And when we roll a die, there's always going to be 6 possible. It's just that the top number is 0. So that's what makes it 0. Yes, there is a denominator there of 6 still. Okay? Now, if we look at the other side of it, what's the probability of rolling a number less than 7? Rolling a die now. What you got there? What is the probability of rolling a number less than 7? Okay, well, again, we're rolling a die, so we're talking 1 through 6, right? So how many successes are there? How many of them are less than 7? There's 6 out of 6. 6 out of 6, 6 divided by 6 is reduced to 1. Yeah. In this case, this event is certain to occur, rolling something less than 7. That's certain to occur, right? And so a certain event has probability of 1. A certain event always has a probability of 1. Which is 100%, if you think about it. Okay? All right. Well, let's think about this a little further then. Am I ever going to get anything less than this probability of 0? If it's impossible, the probability is 0. Can I get anything less than impossible probability of 0? No. I can't do any worse than 0, in other words. Okay? 0 out of 6 is, or 0 out of whatever it is. Can I get any better than this? Can I go higher than 1? No, because I can't, think about this one, I can't go any higher than 6 here, can I? I can't get any more possibilities than 6. So this is the highest number I can get. This is the lowest number in probability I can get. This is the highest number I can get. All the other probabilities fall somewhere between them. 4/9, 1/2, 1/4, some of those that we got before. Everything is somewhere between these two if it's not impossible or certain. Okay? So this is the lowest you can go on a probability. This is the highest you can go. All other probabilities are somewhere between. Okay? See what I'm saying? So this is the upper and lower limit there that you can take, that you can have. All right? So if you get, so that rules out what kind of probabilities. Can I have a negative probability? No. I will never have a negative number that's a probability. Negative probabilities are not possible. I can't have anything bigger than 1. So let's write that. No or bigger than 1. Okay, so if we work one of these problems and we get a negative number for a probability, that doesn't work. If we get a number bigger than 1, 1.5, 1.25, 8 out of 5, those aren't, so we can't have a negative a half probability. We can't have a 1.25 probability. We can't have an 8 out of 5 probability, right? Because those are bigger than 1. That's less than 0. Nothing less than 0, nothing bigger than 1. Okay? All right, so that's kind of a range. Now, let me also mention here, there is another type of probability. What we've been dealing with so far is what's called theoretical probability. There's another probability called empirical probability. Empirical probability, what the distinction is, the difference is, empirical probability is probability based on some sort of data. Whether it's data from some other source or whether you provide the data, whatever. It's called empirical probability. Let me give you, for instance, say I roll a die 20 times and get 12 heads. Well, the empirical probability that I got heads there was 12 out of 20. See that? The empirical probability that I got heads was 12 out of 20. I just took the number of heads I got divided by the total, so it's still successes over total, right? Oh, yes, a coin. Sorry, I was stuck on the die. I flipped a coin. I was stuck on the die mode there. Sorry about that. Flip a coin 20 times. That makes more sense. Flip a coin 20 times and get, say I got 12 heads. Okay? All right. So, you see what I'm saying? The empirical probability I get heads is 12 out of 20. Successes were 12. 20 was the total number of times I flipped the coin. Now, that reduces 12 out of 20, reduced by 4, 3/5. Okay? Now, or that's what percent? Be 60%, 0.6. Now, how is that different than what we were doing previously? Well, previously, when we were doing theoretical probability, well, the theoretical probability of heads should be, what's the theoretical, when you flip a coin, the theoretical probability that we talked about to start our little discussion was a half, right? 1 out of 2, 50%. So that's what we're saying. If we actually do the coin flipping, are we necessarily going to get 50% to occur? Probably not if we do a small sample size, right? If I just flip the coin 10 times, 20 times, there's going to be variations. I'm not going to get, unless I'm very, very good at it, probably, and nobody is that good. If they're that good, you're probably going to be suspicious of them. If they get 50% every time they flip 20 times and they get 10 times heads every time they flip 20 times. But you'd probably be pretty suspicious of them. But that's what we're saying. The theoretical probability and the empirical probability, when you actually do flip the coin or roll the die, they're probably going to be close. They should be close, right? I mean, you don't. If we get 0 heads when we flip it 20 times, that's another case too. Another a red flag there. But you know, this number and this number are going to be close, but they won't necessarily match up. That's what we're saying. When you actually do an experiment, get data like this, your empirical probability is not going to exactly match your theoretical probability. Now, having said that, how could we more guarantee or get closer to the empirical matching the theoretical, you think? Just do more, yeah. Just do it more and more times, yeah. As you do more and more experiments there, if we did it 50 times, we should get closer to the 50%. If we do it 100 times, we should get closer to the 50%. If we do it 1,000 times, we should be getting pretty close. Yeah, that's called the law of large numbers. The more times you do the experiment, the more data you collect, the closer you'll get to your actual theoretical probability. So anyway, just be aware of that other type of probability, empirical. Okay?